So we're back and we're ready to do this problem on our own. So I'm going to go ahead and give you the answer. For those of you who did this on your own, they did not give us A, so we need to find A, angle A. They gave us angle B and angle C, and they gave us side length A, which means we needed to find side length B and side length C. So they gave us 48 degrees, they gave us 37 degrees, and they gave us 18 meters. So for those of you that just want to check your answer, angle A is 95 degrees. Side length B, I went out to the nearest tenth. Even though they had 18 meters, I did go out to the nearest tenth just so that you can check to see, did I do it right? And when we go out to the nearest tenth, usually that helps. If I don't go to the nearest tenth, let me tell you the problem here. It makes it look like I have a Pythagorean triple, or that I've got perfect numbers that come out to be whole numbers. Not a Pythagorean triple because it's not a right triangle, but it's darn close. So I don't know. I just hesitate from doing exactly a whole number without going to any decimal places, but so be it. If you got close to 13.4, you can look back in your calculator, 13.4 and 10.9, you are good. So you've got it. You've got it, and you're probably ready to learn the ambiguous case of the law of sines. For those of you who don't have it, I'm going to draw a picture. So you're still watching. Here's a picture, 48 degrees. And I'm going to have to move this because that's going to be tough, because now I got to draw a 37 degree angle. So I can draw a 37 degree angle right here. Let's do that. I'm going to draw a 37 degree angle right here. And then I could just go back and erase. There we go. And I'll just erase. So, actually, maybe it's a little bit longer. There we go. Okay, had my straight tool off there. There we go. So I try to be as accurate as I can, just because, you know, it's going to help us make sure our answer makes sense. So here I've got 48 degrees, 37 degrees. Well, I can use the triangle sum theorem to get my 95 degrees. So we're good there. Across from the 95 degree angle, I'm going to have the largest side. So 18 is going to be the largest. So my other values should not be bigger than 18. Other values that I find in those side lengths should not be bigger than 18. And now I'm going to set up my proportions. You can set up your proportions using A over sine of A equals B over sine of B equals C over sine of C. And then you can look at the given information. Here's your given information, and you can start writing it down. Or once you draw the picture, you can also use the picture as a guide. So I'm going to have 18 over the sine of what was once unknown, but the triangle sum theorem tells us that that's 95 degrees. So 18 over the sine of 95 degrees is equal to B over the sine of 48 degrees equals C over the sine of 37 degrees. I'm going to cross multiply. B is going to equal 18 times the sine of 48 degrees all over the sine of 95 degrees. So I take 18 times the sine of 48 degrees. Remember that this is just a ratio. This is just a number. It's a number. So 18 times some number divided by, again, this is a ratio. This is just some number divided by a number. And that's how we get approximately 13.4 meters. And then C is equal to, C is going to equal 18 times the sine of 37 degrees divided by the sine of 95 degrees, which is approximately 10.9 meters. So I'm going to come back up here, write meters, And my answer is that right there. Now I'm going to check to make sure my answer makes sense. So those of you who are sticking with me throughout this entire explanation, the largest angle is right here. Largest angle is across from the largest side. The smallest angle, that's this one, smallest angle is across from the smallest side. So our answer makes complete sense. And that's how you solve using the law of sines. So hopefully these two examples, an example and a try, has helped you, maybe given you some confidence that, hey, I'm ready for the ambiguous case of the law of sines. It sounds sketchy there, but it is. It's ambiguous. It's an ambiguous case of the law of sines, and it happens all the time. Not all the time. In a certain situation. In a certain situation, it happens all the time. And I'm going to tell you what that certain situation